In this video, I'll introduce you to the concept and application of blocks in AUTOCAD. Blocks are effectively used to handle with repeatability in a drawing. If you take an engineering drawing, for example, a mechanical drawing, you will see the symbols of nuts, bolts, washers being repeatedly used at several different places. Similarly, if you take an architectural or a civil drawing, you will see the symbols of doors, windows, ventilators and other furniture symbols like sofas, chairs, tables, etc. being repeatedly used at several different places. But if you make use of blocks, you can effectively deal with this repetition. But if you do not use blocks, then the next alternative would be to use a copy command. But if you use copy command, you will end up in creating more number of objects. Let's take for example, in this drawing, I have used the W2, this 2-panel window, several times. And I'll just take a copy of this W2. And now when you click on the W2, you can see that it's a single object because it's a block. You can convert this into segments using the explode command. So I'll give X and select this. Now when you click on this, you can see that it's all split into several segments. And when you make a selection, you can see that it is made up of several objects. That means in a situation when you want to make several copies of the same window, you will end up in creating more number of objects, which will increase the file size as well as regeneration time when you work. This is where you actually need to make use of blocks. In addition to handling with repeatability, AUTOCAD blocks gives tremendous amount of advantage in editing. We will cover all these details in this tutorial. We will try the concept of block in this figure. We have already created this chair in the chapter of grips and arrays, and if you need any clarifications on the process, you can please go back and refer that tutorial. This figure is made up of several objects. How will you know the number of objects? Just give erase command or any editing command and you select the number of objects and you will get a message that there are altogether 5 objects. Suppose in a drawing you want to make 100 such chairs, then you will end up in creating 500 objects altogether. You can reduce the number of objects in this drawing by combining all these 5 objects into a single object. That is exactly what you do when you make a block. You can create a block in AUTOCAD using 3 different methods. In the first method, you make a block of these 5 objects and you combine all these 5 objects into a single object, and you can use that particular block inside this drawing. Let's see this procedure first. If you want to make a block, you have to click on the Create Block icon in the block panel, which comes under the Home tab. Alternatively, you can type the command BL for block using the keyboard at the command prompt area. I'll click on the Create Block icon, so you will get a block definition dialog box. Here you have to specify a block name. I'll give the block name as chair. Then the software will ask you for 3 informations. You're supposed to give the base point, objects that are to be blocked, then you have to specify certain parameters like you want to scale it uniformly, you want to make it annotative, etc. I'll specify the base point using pick point method. So I'll click on pick point and I'll choose this midpoint as a base point. So the coordinates of that particular point will appear here, or else you can directly give X, Y and Z values here. Then it'll ask you to select the objects that are to be blocked. So I'll select the objects using a window. Then you have options like retain, convert to block and delete. I'll choose delete from this and I'll give OK. Now the object on the screen will get deleted. If you want to fully understand what exactly happens when you make a block, you should understand the concept of a block. So when you create a block in AUTOCAD, the software writes a block definition into the invisible block table area of your drawing file. So where exactly this block table area residing? If you want to fully understand this, you should explore the architecture of a drawing file. So let's explore the architecture. Your drawing database consists of 2 areas. One is called visible area, then we have the invisible area. The visible area consists of the parametric data such as the end point of a line, the center point of a circle, radius of arc, etc. All those parameter related informations related with objects. Whereas the invisible area consists of non-parametric data such as the information about the layers. As we have discussed in the last video tutorial, you can have as many layers as you want in a drawing, but at a time you won't be able to see the number of layers and the related informations because the information about the layer is in the invisible area of the drawing file. Same is the case with blocks. That means when you create a block, the block definition exists in the invisible block table area. So that is how the block is written. And from this definition, you can create any number of copies depending upon the requirement. Now we have the block existing in your drawing as an invisible object, and you can create any number of copies of this object, and you can see it on the screen using the insert command, and you can bring it to the screen using the insert command. So I'll click on the insert block icon. Alternatively, you can type the letter I at the command prompt. When you click on the insert button, you can see the block definition here, because here you have the block table area which is displayed, and if you can either directly click on the definition and you can insert it. Now it will ask you for an insertion point. I'll just click to insert it because this is where I want this particular block to appear. Now when you click on the object, you can see that the whole thing is a single object, even if it is made up of 5 objects. So it will be very easy for you to select it once you make it a block. The objects in this block is existing in the 0 layer. When you create a block with the objects in the 0 layer, the block will readily accept the properties of the layer in which it is inserted. Let us just check that out. So I'll go to layer properties, I'll create a new layer and I'll call it as room 1. Then I'll create another layer with room 2 as the name. Then one more layer and I'll call it as room 3. Okay, and for each layer I'll assign a particular color. And for room 2 I'll assign this green color, and for the room 3 I'll assign the blue color. Then I'll make the room 1 as the current layer, then I'll go to insert, then I'll insert the chair. So you can see that this particular block reference has accepted the property of the layer. Then I'll make room 2 as the current layer, then I'll go for one more insertion of the same chair. Okay, it has accepted the property. Then I'll make room 3 as the current layer, then I'll go for one more insertion, and it has accepted the property of that particular layer. So this is the advantage of creating the objects in a block in 0 layer. Now when you explode these blocks, it will lose the block property and the objects will go back to the 0 layer. Now when you click on it, you can see that these objects are in the 0 layer. But if it remains as a block reference, these objects will remain in the layer in which it is inserted. Suppose if a block has got objects in different layers, once you explode such a block, those objects will go back to the respective layers. Then I'll also go for one more insertion here, but this time I'll go for more options. So when you go for more options, you will get this insert dialog box. Over here, you can specify certain parameters such as the location of insertion point, the scale factor and the rotation angle. And these 3 information can be specified either on screen by activating this particular button, or else you can specify this information in the dialog box. So I want to specify the insertion point on screen, whereas the scale factor I would like to specify on the dialog box. And I want this scale factor to be a uniform scale factor. So whatever scale factor provided in the X direction will also be applicable along the Y and Z directions. So I'll give 0.5 and I'll give OK to insert it on the screen. When I just click over here, you have got the same block here inserted, but the size of it is reduced by half. I'll give one more insertion using the insert command I. Now I'll get the same dialog box, but this time I'll disable uniform scale so that I can specify individual scale factors. Along the X direction, I would like to give a scale factor of 0.7. And I'll give a rotation angle of 45 degrees. This is a scaled down version of the same block definition in the X direction by 30%, and it is rotated through an angle of 45 degrees in the counterclockwise direction. These 3 objects are nothing but the copies taken from a single definition, and these 3 copies are called references. So what is a definition? So definition is a hidden object which remains inside the invisible block table area of the drawing database, whereas the reference is a copy taken from the definition. The software establishes a link between the definition and the references, because of which any changes performed on the definition will get instantly reflected on all the references. This procedure is called block redefinition. Let's see the procedure to perform block redefinition. I'll erase these 2 reference objects. I'll go to erase and select these 2. Now I'll just zoom out a bit. I'll take multiple copies of the same chair using the copy command. My requirement is to redefine the definition so that it will get reflected on all the references. In fact, you can perform block redefinition in 2 different methods. In the first method, you can select the block reference, then you right click, and here you will get an option called edit a block in place. Just click on that. So you will get a reference edit dialog box. The same dialog box can also be obtained by inputting a command ref edit. So it will ask you to select the reference. This is the reference. You will land up into the same dialog box. Now it will display you the reference name as well as the preview of the reference. I'll give OK. When you do this, you will get a new panel at the ribbon, and this is called Edit Reference panel. In this panel, you will get a number of options. We'll come to that. Now you can incorporate the required change. But when you go to Edit Reference, only the parent object is displayed and rest of the objects will be in the hidden state. Now what you see on the screen is the parent object. Now I'll select this particular chair. I'll make some changes. I'll perform grip editing of the center grip. So I'll convert this into arc. I'll make it curvular and I'll fill up this particular portion. So I'll do that with the help of hatch command. If you want to perform hatching in AutoCAD, you can just type the letter H for hatch. Select an internal point. I'll just make a pick here. Now it will ask you to select the pattern, and I would like to go for a solid pattern. You can select a solid pattern, and I would like to give a color for the pattern. So this is the change I have performed. Now I would like to save the changes which I have performed on the definition. So you can just click on Save Changes button. When you click on Save Changes, the definition will get changed. Since the software establishes a link between the definition and the references, this change will get reflected on all the references. Just give OK. So this is it. In a single click, you can perform such a perfect editing operation. The second method is by using a separate interface called Block Editor. How will you get it? Just select the reference, right click, and you click on Block Editor option. Now you will get a different interface. Here you have a separate palette. We'll discuss about this later when you talk about dynamic blocks. And over here, I can incorporate any desired changes. For example, I want to perform another hatch inside this area. So what I'll do is I'll give hatch command, type the letter H. Now I'll just pick a point inside and I'll choose a different color. Let it be this shade. Then I'll click on Close Block Editor. So the software will ask you, do you want to save these changes to the block definition chair? Just click on that. These are the two methods to perform reference editing in AutoCAD, in which you perform editing on the definition and the changes will get reflected to the references. The definition can also be treated as a parent object and the references are the child objects. So any changes performed on the parent will get reflected to all the children. Now this block which we have created just now is currently available only in this drawing. But you will be able to make the best use of this particular chair if you can insert it in any other drawing. So this block can be treated as a local block. Next we will see the procedure to globalize this block. Once you globalize a local block, you will be able to access that block in any other drawing. This is in fact the second method to create a block. So the command is wblock or right block. So you can give the shortcut WB using the keyboard. So you will get the right block dialog box. You can derive the source objects from a local block, or from the entire drawing can be globalized, or you can select certain objects after specifying the base points to globalize those objects. But right now, since I have a local block, I can choose the block option and I'll select the block. Here the software displays the block table area, so I'll select that. But here you have an option, that is file name and path. If you want, you can redirect to any desired path. I'll redirect it to, I'll create a new folder, right click, new, I'll call it as WB and I'll save it. AutoCAD is now trying to create a drawing with the name chair.dwg. I'll click on save. From this, it is clear that when you globalize a local block, the software creates a drawing file for you. Now you can specify the default insertion units. Presently I'll keep it at millimeters, give OK. Now let's go back to the folder and check out whether that drawing is created. I'll minimize AutoCAD. Here you can see the folder called WB which you have created. Now we have a file chair.dwg created by the software here. I'll just double click to open this file and it's not visible. You have to go for a zoom extents. So double tap the scroll wheel of the mouse to get it. Now you can see the chair created. So when you make a world block, AutoCAD creates a drawing file for you. And how will you insert this drawing file in any other drawing? Let's open a new file. I'll open a new file using the file new drawing and I'll just give open. Next I'll go for insert command, click on insert. Now this area is empty because in the insert command this area displays the block table and presently this is a blank file, so absolutely there is no objects here. So you can use the browse option. Then you come to desktop and go to WB and you select chair.dwg, open and OK. Now I'll just click to insert this particular block here, and what you see on the screen is the block reference, a copy of the definition. You might sometimes think that the definition of this particular reference is that external drawing. In that case, any changes performed in that external drawing should get reflected here, but that will not happen. So the actual definition of this reference is created right in this drawing. Let's check that out. I'll click on insert command and you can see that the definition is created here, and the software establishes a link between that definition and this reference. And when is this definition created? Let's find out. I'll undo all the operations I've done. Now this is just a blank file. Next I'll go for insert. Presently the block table area is empty, and I'll go for browse and I'll choose this chair and I'll give OK. You can see a little preview of it. Instead of inserting this chair, I'll press escape to cancel this operation. Let's find out whether the definition is created. When you click on insert, you will see the definition here. So the moment you see the preview while inserting the external drawing, the software creates a definition in the block table area. What you see on the screen is the reference object of that particular definition. I'll perform some insertions of the chair over here. One more insertion. Okay, and one more. Now the link exists between the definition in the current drawing and this particular reference, and it is no way related with that external drawing. Now I'll just right click and click on edit block in place and give OK. Let me just make some change here. I'll drag it and I'll keep it like this, and I'll erase this hash pattern. So that's a change. I'll go to edit block reference and save these changes and I'll give OK. Now you can see the changes getting reflected on all the references. This is the second method by which you create and use a block. Let's recollect the procedure. First, I had a local block in this drawing which was created using the block command, and using the wblock command I have created an external drawing. Then I have opened a blank file. Then using the insert commands browse option, I have inserted that particular external drawing into this file. When I have inserted, the moment I saw the preview, the software automatically created the definition in this drawing. Then when I have inserted it, I have got a reference, and the link always exists between the definition in the current drawing and the reference which is visible on the screen. So that external drawing was actually used as a block. This clearly indicates the fact that you can insert any other drawing into your drawing. But to create that external drawing, you don't have to actually go through all these procedures of making a local block, then by using wblock command, you have created that external drawing. Okay, this procedure is always not necessary. So whenever you want to make a block that is to be inserted in all the drawings, you can straight away make that drawing. Then we will save it in a proper name and in a proper location. And later on, using the browse option of insert command, you can insert it in any other drawing. Let's see that procedure. I'll open a new file. It's just a blank file. Then I would like to create the symbol of a bed. Because you know, the symbol of a bed needs to be used in civil architectural plans and interior drawings. I'll start with a rectangle first. Pick the first corner here, go to dimension option, and I'll give 180 by 180. 180 as the length and 180 as the width, and click to define the opposite corner point. Okay, it's 6 feet by 6 feet. Now we have to add 2 bed boxes. So I'll go to rectangle again. By giving an enter, you can repeat that command. Then I'll click on the first corner. Then go to dimension option and I'll give 45, 45 as a length and width. These are all in centimeters. Okay. Then I'll move this bed box and I'll keep it right over here. Then I'll take a copy of the same box and I'll keep it over here. Next, I'll make a rectangle here to indicate head side of the bed. Then I'll go for rectangle, create the first corner here, go to dimension option, length is 180 and the width is 6 centimeter, and I'll click to define the opposite corner point here. Another rectangle is to indicate the pillow. Just you can drag to define the corner points. I'll go to fillet command and I'll go to radius option. Pick 2 points on the screen to define the radius. Go to polyline option and click to fillet all the 4 corners simultaneously. Next I can go to mirror. This is the object to be mirrored. First point on the mirror line, next point on the mirror line. Okay, let this indicate the symbol of a bed. Now I can save it in a particular name. So I'll go to save as, then I'll call it as bed in the same folder WB. and I'll save it. Let's open a new drawing again, and I would like to insert this bed here. Next I'll go to rectangle. I'll create a room. So I'll pick the first corner here, go to dimension option, and I'll give a length of 450 and I'll give a width of 550. Okay, this is the room. Then I'll give offset and I'll give a wall thickness of 20 centimeter. Select object to offset, side to offset. This indicates the bedroom. Now I want that particular block to be inserted here. So I'll go to insert command. Presently this is a blank file, so the block table area is empty. Now go to browse, take bed and open and OK. Now you can see the symbol of the bed, but the problem is, see, you have the insertion point at the cursor location which is far away from the bed. I want this particular bed to be inserted exactly against this wall. Okay, so you will find it a bit difficult to locate it precisely since the insertion point is not properly specified. Then you have to give an additional move command. Then you can select this bed, then this is a base point and this is a second point. So how will you rectify this problem? If you had the insertion point specified right here, you could have inserted it in one go and eliminated the move command. So there is a solution for that. Let's go back to the bed file. Then there is a command called base, using which you can re-specify the base point of a drawing. The default insertion point or base point of a drawing is at the origin. Now I want to re-specify it. For that, you just go to block and here you have set base point option. So click on that. So it will ask you for a base point. Alternatively, you can also give a command called base using the keyboard. I'll click my base point here. Let me change the color of this bed. So I'll choose a suitable color from here. Let it be this shade. Then I'll save it. Let me go back to the file. Then erase it. Then go to insert again. Okay, but when you go to insert, you will see that bed as a block definition. But I need the latest drawing. So go to more options and choose browse once more. Don't take this because this is the previous version of the definition. So go to browse again and take bed and give open and OK. So the software will tell you that the block is already defined. That means a block with the same name is already existing in this drawing. Do you want to redefine it? Yes, click on that. Now you will see this block with the latest base point specified. Now in one go, you can click it at the right location. This is the advantage of re-specifying the base point of a drawing. Now we have discussed 3 different procedures to create blocks. In the first method, we have created a block in a drawing using the block command, and that block will reside only in the current drawing. Such a block is called a local block. And if you want to access this block in all drawings, you can use the command wblock and you can make an external drawing file which can be inserted using the browse option of insert command in any other drawing file. We need to create drawing files this way only when you have a local block existing in your drawing and that need to be globalized. In the third method, we create a drawing right from the scratch just as we have done for the bed. Then using the base command, you re-specify the insertion point from origin to a convenient location. Then you save that file. Such a drawing file can be inserted in any other drawing using the browse option of insert command. This is exactly what is preferred. As you are aware, blocks are effective methods to handle with repeatability, and whenever you feel that a particular component in a drawing need to be repeatedly used, you open a new drawing, then you create that component there, re-specify the insertion point using the base command, save it. Then you can insert that particular drawing any number of times in any other drawing. So that is the sum and substance of it.